This is part 2 for lesson 5.2, solving quadratics by completing the square. So before we go through this, you should have already tried at least 4, 5, and 6 by yourself. I want you to just see what the issues are, what your questions are, and then that way when I go through it, you'll be able to know, oh, that's how I do it. Okay, so number 4, we're starting to see some things that are going to make this a little bit harder. So I do notice that I have a 1 coefficient, so that's good. I don't have to worry about that. I'm going to go ahead and I'm going to add the 51 to the other side and just get it off the left-hand side. So I'm just going to be left with x squared minus 20x, and then on the other side I'm going to have 54. Obviously I should write 20x and not 2. That would be different. Okay, so the next thing I'm going to do is I am going to complete my square. So this needs to be a perfect square trinomial. So what number do you have to add right there to make this into a perfect square trinomial? Now sometimes, like in this question, the numbers work out pretty nicely. So you take half of 20, which is 10, and you square it. So this, I'm going to write this as 20 divided by 2 squared. That's what I'm adding. I know that that's 100 because I know that 20 divided by 2 is 10 and squared is 100, but I'm going to write it like that just because it will help for some other things down the road. But I'm just going to show you that that's what we're doing. So this part right here that's a perfect square trinomial now, I can write that. So it's going to be x. This minus sign right there tells me I'm going to have a minus. And then the square root of this number or half of that number squared. So it's going to be 10. Okay, or sorry, half of the number, not squared. So I'm going to have x minus 10 quantity squared equals 154. Now going to take the square root of both sides to solve, I'm going to have x minus 10 is equal to plus or minus the square root of 154. Okay, so here's where it gets a little bit different. You need to check and see if you can simplify that radical. So 154 is going to be 2 times 77, and that's 7 times 11. So 2 times 7 times 11, that does not simplify. So my solution is going to be x such that x is equal to positive 10, because I have to add 10 to both sides, plus or minus the square root of 154. And that's how you're going to leave it. This is an irrational root. So this means you could not have factored this. Now usually when we get an answer like that, it feels kind of uncomfortable. We're not really used to seeing solutions that look like that. So try this on your calculator. Type in 10 plus the square root of 154. Store it in your x button. And so your screen says, when you say store, it gives you a little arrow and you're going to put it in x. And it has to be the x button. Don't do the alpha button. Do the one that says xt theta, that one. And then you're going to type in your original equation. So in your calculator, you're going to say x squared minus 20x minus 51, hit equals. It should be 3 because that's what it was originally. And then you can go back and change the plus to a minus, do the same thing, store it in x, try it, and you can make sure. So you can validate your answers. You can make sure that they're really true. So these two solutions, like I said, with quadratics, you always have two solutions, but that's what they are, these right here. Okay, let's go to number 5. Again, we see that I have a 1 coefficient, so I like when I see that. On the practice, there's no more with something other than 1 on your homework. There will be, so you're going to need to go back and refer to that example that I showed you, and I showed you a couple different ways to do that with either factoring it out or you could divide everything. Anyway, back to this one. I'm going to do the same thing. I'm going to get the 58 off of that side, just move it away. I'm going to be left with n squared minus 16n. I'm going to leave some space because I have to complete my square. Negative 10 and negative 58 is negative 68. Okay, I'm going to take half of 16, which is 8, and square it 64. So then I'm going to add the same thing to the other side. So now my perfect square trinomial is n minus half of 16 was 8, or the square root of 64 is 8. And then on the right-hand side, I've got negative 68 plus 64 is negative 4. Okay, so this one, you might be able to see this is going to bring up a whole other issue. So I'm going to take the square root of both sides, and I'm going to have n minus 8 is equal to plus or minus, what is the square root of negative 4? So remember we learned about imaginary numbers, and that's going to be the square root of 4, which is 2 times 2, and then negative 1, which is I times I. So the square root of that is 2i. And so you're going to solve for n by saying n is equal to 8 plus or minus 2i. And those are your answers. They're imaginary solutions or complex solutions. And so, again, when we get to Unit 6, we'll talk about the meaning of that and what does that mean for our equation. But you can still check this in your calculator. So you can type in 8 plus 2 and then use the I button above the decimal, store it in x, and then you can type in you'll have to do x instead of n, but x squared minus 16x plus 58 and hit equals, you'll get negative 10. It's pretty cool how that works. And then, of course, you can do it with the 8 minus 2i. So when you write your solution, so you have two solutions, okay? The plus gives you one of them, and the minus gives you another one. If you wrote them separately, it would be this as a complex number, okay? But usually we just write it like that. There's no reason to write them out separately. For the rest of the examples, I've chosen problems that are going to give us different issues that come up that you're going to see. So you want to pay close attention to how we deal with all of the different things that are going to come our way in the next few problems. So if you want to pause and try number 6 if you haven't already done that, but if so, let's just work through it. So I'm going to do the same thing. This time I'm going to keep the 39 on this side, and I'm just doing that to just show you how you would do it that way, because sometimes that's good to do and sometimes people just do it. It's kind of a personal preference. But I'm just going to put the 39, I'm going to just scoot it over and make some space for my completed square, but it's still on the left-hand side. So when I go to complete my square, what will I be adding? I'm going to take half of 2, which is 1, and square it, so 1. Now I can either do a plus 1 right there, or what we could also do is we could just say, then I'm going to take away 1. So if I add 1 and take away 1, nothing ever happened. And so this is what manipulating the equation is. It looks like that because you're making it looks like something that's useful to you, but you haven't changed the value at all. So that's what I have now. So I'm going to move my 38 to the other side. And so negative 38 plus 9. Okay, so when I go to take the square root of both sides, you can see that we're going to have imaginary roots again because I'm taking the square root of a negative. Now 29 is prime, so there's nothing I can do with that, but the negative I can do something with that. So I'm going to have plus or minus I square root 29. And try when you do your I, do it like give it a little tail there so you can tell it's not a 1 or something. And then I'm going to solve for m by subtracting 1, so m equals negative 1 plus or minus I square root 29. And so those are my solutions. Again, you can try them in your calculator to check. And so on your test, if you are allowed to use a calculator on the part that you're doing this on, you can check. If not, you just need to be super careful. Let's go ahead and go to number 7. Okay, again, I check for my leading coefficient. If the leading coefficient is not 1, remember, you're either going to have to factor it out or divide everything by that number. And sometimes the factoring works better because then you don't have to make everything into fractions. Sometimes the dividing works really nicely, like on number 2 or number 3. That would have worked just fine there. Okay, let's go ahead and get into this one. So we're going to separate that. That's 19x. I'm going to leave some space, keeping that on the same side. You can move it to the other side if you'd like. You're welcome to try and do it that way. Find what you like to do. Now this one, you can see that we do have an issue because when I go to take half of 19, that does not look pretty. So I'm going to take half of 19. We are not going to use decimals. We're going to do 19 halves, and then we're going to square it. So 19 halves squared is 19 squared over 2 squared. So you can start to see, like, this is why I wanted you to know your square numbers. This is why we've worked with fractions, because we have to use this kind of thing. I'm going to take away the 361 over 4, and we'll deal with that in just a second. That's going to be its own problem. Okay, so we're going to worry about that in a minute. This right here is going to be x plus, because there's a plus right there, and then half of 19, so 19 halves, which is the square root of 361 fourths. So that's going to be my perfect square. Ugly, yes, but it's still a perfect square. Now over here I've got all this other stuff to deal with. I can keep this part that I have in the red parentheses, I can keep that on that side and then move it to the right, but I'm just going to move everything to the right hand side and just worry about it over there. So I'm going to have negative 3 minus 96 plus 361 over 4. Now when I have fractions, remember you have to have common denominators. So in order to add all of that together, I'm going to have to make common denominators. So that's going to be negative 12 fourths. 96, to make that into fourths, I'm going to need to multiply it by 4, and that's going to be 384. So minus 384 over 4 plus 361 over 4. So that's what I have on the right-hand side. So since they're all over 4, I'm just going to have that, and then I can get my calculator and do negative 12 minus 384 plus 361, and I get negative 35. So none of this is looking really pretty. We've got, the 19 halves and the negative 35 fourths. So we have to be able to deal with fractions and all the numbers that we have to encounter in these types of problems: imaginary, complex, fractions, irrationals. So I'm going to go now and I'm going to solve for x. I'm going to take the square root, both sides. On the left-hand side, I'm going to be left with x plus 19 halves. Do not turn that into a decimal. On the right-hand side, I'm going to have plus or minus. Okay, now 35 is 7 times 5, so I can't do anything with that, but I can do something with the negative. And so I'm going to have I is going to come out on the top. On the bottom, I've got the square root of 4. Remember that this is the square root of negative 35 over the square root of 4, so I can do that. So that's going to be over a 2, and then I'm going to have the square root of 35 on top like that. So that's what that fraction is going to look like when it's simplified. So now to solve for x, I'm going to subtract 19 halves. Okay, last thing, because these have the same denominator, I can write them as one single fraction. And so when we're dealing with quadratics, that's usually how we will write our answer, as one single fraction. And so those are my weird solutions that I have. They look very uncomfortable. You can try it the way you would put this in your calculator. You would do parentheses to separate off your numerator. So negative 19 plus I square root 35, and then close your parentheses, divide by 2, and then store that in your x. And then you would type in your equation, your x squared plus 19x plus 96, and it would equal negative 3. And so that's how you would do that, and to make sure that those are your solutions, and then write it in set notation. Okay, number 8. This one, the numbers are smaller, but you can see that we're still going to have the same problem with fractions. We're going to have to deal with that. So I'm going to take this part and separate it. I'm going to go ahead and add the 30 to both sides. So I'm going to have p squared minus 5p equals, and then negative 5 plus 30 is 25. Okay, to get my completed square, okay, I'm going to have to take half of 5, so that's 5 halves, and then I'm going to square it. So that's going to be 25 over 4. So when I write my perfect square trinomial, it's going to be p and then minus, and then the number that goes there, it is either the 5 halves, if you want to do this divided by 2, or it's the square root of that number. So however you want to think about it, but that's what's going to go right there. So that's your perfect square trinomial. If you were to multiply that out, you would get p squared minus 5p plus 4, or 25 fourths. Okay, and that's equal to 25. So I'm going to take the square root. Don't forget that you have to do the plus or minus. So you're going to have p equals 5 halves plus or minus 5. Now, even though those are not both fractions, they are both real numbers, I can add them together, and we're not going to do decimals. So we're going to have 5 halves plus 5 and 5 halves minus 5. And so that's going to be 15 halves, and this is going to be negative 5. Whoops, this is 2 right there. 5 halves. So my solutions that I'm going to write in my set notation, oops, not x, p, such that p is equal to, I'm going to have 15 halves and negative 5 halves. Don't turn them into decimals. We're going to leave them as fractions. We just don't have a need to turn them into decimals at all. Okay, the last one, we're going to do an application of quadratics. So whenever you are throwing something in the air, or when, gravity is working on something, something goes up, has to come down. And so it forms a parabolic shape. And so a parabola is described by a quadratic equation. So the applications that we see for quadratics have to do with kind of a motion like that. So something going up, something coming back down. And so this one, it says a pet owner throws a tennis ball for his dog to chase. So if you throw the ball, it's going to go up and it's going to come down. Okay. Gravity on Earth is stable and constant, and it's negative 32 feet per second. And so when we deal with a gravity type equation, you are going to see something that always is going to be true, and that's going to be the leading coefficient. The leading coefficient in an equation like this is going to be negative 16, and that's the gravity divided by 2. All right, so the negative is because it comes down. Divided by 2, I'm not really sure why that is. A physics teacher could probably tell you better than me, but that's always going to be the case. Now, if we were on a different planet, that number would be different. But here on Earth, that's our number. So whenever we have a quadratic equation that has to do with something like this, with gravity, something coming up, something coming down, something falling, somebody jumping, whatever, it's going to have the negative 16x squared. This in the middle, that's our velocity. Okay, so that's telling us the speed at which something is happening. So because he's throwing the ball, he's putting some force behind it. This right here is our initial height. So when he lets the ball go, it's 4 feet off the ground. So that's where it starts from. And so those numbers all tell us something, and we'll deal a lot more with that as we get into Unit 6. But that's just kind of a little introduction to that. So it says the tennis ball's height in feet, x seconds after it's thrown, is given by this. So negative 16x squared plus 32x plus 4. So if we were saying like 3 seconds after the ball left his hand, we could plug in 3 for x, and 3 for x and find out how high it was off the ground. Okay, now it says when will the ball hit the ground? So think about what's happening. Okay, the guy is throwing the ball, and it's going to go up, and it's going to come down. Eventually, it's going to hit the ground. So what is the height when it hits the ground? The height when it hits the ground is 0. And so what we're doing is we're solving this equation for when x is, or when the height is equal to 0. So it's just more of a factoring type thing. So this kind of brings into play, like if I divided everything by negative 16, that would work really nice for those, but it does not work nice for that. So the 4 divided by negative 16 is kind of the problem. So I'm going to actually not do that. What I'm going to do here is I'm going to utilize the factoring idea. So I'm going to take out the negative 16 out of not all the terms, but just the first 2 terms. And notice how I did a minus 2x because negative times negative is positive. So watch your signs there. And then I'm going to leave some space to complete that square. I'm going to have the plus 4 hanging out over there. I'm not going to move it to the other side yet. Inside my parentheses, I'm going to complete that squared. So half of 2 is 1, square it is 1. Now here's the key. What did I really just do? I didn't really just add 1. I really subtracted 16. So to make up for doing that, I'm going to have to add 16. Or I would have to subtract 16 from the other side. You choose. You just have to make sure that it's even. So if you do something to one side, you do the exact same thing to the other. If you're going to stay on the same side, you have to just undo it. So if you add, then you would have to subtract. So I'm going to just put that there. So, whoops, add 16. So I'm going to have the negative 16. I'm going to have my perfect square. The 16 plus 4 is 20. Now to solve this, I'm going to have to get the x by itself. So first is going to go the 20. Then I'm going to divide by negative 16. So negative 20 divided by negative 16, I'm going to simplify my fraction. So negative 20 divided by negative 16 is going to be positive, and 4 goes into both of them, so 5/4. So I'm going to have x minus 1 quantity squared equals 5/4. I'm going to take the square root of both sides. So x minus 1, actually I don't need the parentheses there, equals plus or minus. Okay, now the square root of 5/4 is the same as the square root of 5 over the square root of 4. And so just to simplify, I'm going to write the square root of 5 over 2. And then I'm going to move my 1. So x equals 1 plus or minus the square root of 5 over 2. Write that as a single fraction. Okay, that's how we do this. And so you're going to have to change the 1 into halves. So I'm going to have 2 halves plus or minus the square root of 5 over 2. So that's going to be 2 plus or minus the square root of 5 all over 2. And that's going to be my solution. Now, when we deal with fractions like this, which we're going to start to deal with fractions like this a lot, you cannot cancel that because those are terms. You can only cancel factors. So that's why that would be simplified. Now, because this is a real-life problem, let's go back and look at the question. It says, when will the ball hit the ground? So what are you going to say? 2 plus or minus square root of 5 halves seconds? That doesn't make any sense in this problem. So in this problem, it does make sense to turn it into a decimal. So you're going to get your calculator, and we're going to type this in. Now, if I was backing up, if I would have, since it is a story problem, like I could just put that in my calculator. It's not really going to matter that I have the simplified radical, But you are going to have problems with simplified radicals, so I just want you to make sure you know that that's how you would simplify that. So I'm going to type this into my calculator, 1 plus the square root of 5 over 2, and I get 2.1180 and then some other numbers. And then when I do 1 minus the square root of 5 and then divide it by 2, I'm going to get negative 0.118. So I want you to make sure that you're getting those numbers in your calculator. If you're not getting those numbers in your calculator, you need to go back and look at your order of operations. How are you typing it in? So make sure you're getting those numbers. Now, the question was, when will it hit the ground? So that's about, and does it say rounding? It doesn't say rounding. So if it doesn't say it, I would say go to the nearest hundredth is usually a good rule of thumb. So 2.12 seconds after. What does this mean? This is another encounter with what's called an extraneous solution. Okay, so we talked about that a little bit before, but extraneous solutions are solutions that algebraically work. So this would solve the equation, but because of the type of problem, it doesn't make any sense. So it actually is not a solution to this problem. So the only answer to this question is actually 2.12 seconds. And so when you have an extraneous solution, you should show that it's there, but then show that you're going to throw it out. And that way, if I'm looking at your work, I know that you found that answer, but you also recognize that that's not going to work. Okay, that's it for completing the square. So you now should be able to complete your homework. There will be some questions on the homework where you have to take that leading coefficient and deal with that. Not very many problems, just a couple. And so if you want to try that, and then if you need to check with the answer key, you can see how you're doing, and then come back with any questions that you have.